And we're going to talk about the fundamental theorem of algebra today, but you already know it. I just haven't called it this. And it's really just this little piece at the top of the page in the 5-9 notes. And then there's a couple lines we're going to fill in here in a second that are separate. But that's your fundamental theorem of algebra. If you have a polynomial equation, then the number of solutions, roots, zeros, whatever you want to call it, is going to be equal to the degree of the polynomial. So we look at that leading term, and you just grab the exponent, the highest power of x. That tells you how many solutions the polynomial has. So we've been talking about this all throughout this entire unit, so you already know it. I just didn't call it the fundamental theorem of algebra. What we're going to do today is talk about how those zeros or roots can shake out based on the polynomial and all the different options you could have for how those solutions, would they be imaginary, would they be real, and how could you tell? Okay, so the first little thing I'm going to fill in here, why do I not have a marker? Imaginary roots. All right, we did this yesterday. So they always come in pairs, so in groups of two, because if you have a conjugate, you automatically have, or if you have one imaginary root, then you automatically have its conjugate. So they have to come in pairs. If you have one, you automatically have two anytime you have an imaginary solution. So they have to come in pairs, so they have to come in even numbers. If you have a real root, okay, now just to give you an example, so like a real root, you could have, I don't know, something like 5/3. You could have -6. You could have, maybe you have a nasty, like, irrational number, like, I don't know, 2 plus the square root of 3. Those are all real roots. They're real numbers. They don't have an I involved with them. The irrational roots also come in pairs, but this would be seen, if you can see a real root on a graph, which is what I'm going to write here. Real roots are going to be visible on the graph of the polynomial, and all they're going to be is where the graph crosses or touches the x-axis, so it would just be what we call x-intercept. So you can see those on the graph. The imaginary you cannot see on the graph, so if I give you a graph and say, okay, how many real, how many imaginary, you can't tell how many, or you can't see imaginary roots on the x-axis. Visually, I can see real roots, whether they be a nice number or whether they be an irrational number. Okay, now we're just going to make a little table here. So I'm going to give you just the leading coefficient, or the leading term of the polynomial. So we don't have the polynomial, we can't graph it. And what we're going to do is we're going to write down all the possible ways that our solutions could shake out in terms of how many real and how many are imaginary. So if I just start, this just says the leading term is 5√6. I don't have the rest of the polynomial, I just have the leading term. We can tell how many solutions it should have just from looking at that. So how many roots or zeros would you have if your leading term was 5x to the 6? 6. Okay, now you're going to write out the possible ways that this could shake out. So what I always do is I start with imaginary numbers. So I know imaginary numbers have to come in pairs, like we wrote at the top. So I could have no imaginary. I could have 2, because they have to come in pairs. I could have 4. I could have 6. I would not go up to 8. Does anybody know why? Riley, what do you think? You only have 6 solutions. Okay, so we wouldn't go any further than that. All right, now here's how this works. So each one of these, I'm going to just write this to the side. These would be, in this case, if you have a 6th-degree polynomial, there's 4 different ways that your zeros could shake out. So the first way is just like the top line in that little table I made. So if you have no imaginary solutions, how many real solutions would you have to have if you have a 6th-degree polynomial? Hunter, what do you think? 6. So the line would just add up to 6. So if you have 2 imaginary, then you'd have to have 4 real. If you have 4 imaginary, you'd have to have 2 real. They have to add up to 6. Bless you. If you have 6 imaginary, then all 6 would be imaginary, and I wouldn't have any real. So you have 4 different ways that that could shake out. We just have the first term, so we don't know the rest of the polynomial. We can't look at a graph. So those are all the possible combinations that could shake out. All right, if I look at negative 2x to the 5th. How many solutions would that have? Rudy, what do you think? 5. All right. So again, I just start with the imaginary. So they have to come in pairs. So I just start with 0 and just even numbers. 2, 4, would I go up to 6? 6 would be too many because I can only have 5. So it would just be, for this situation, we would have 3 options. Now, all you have to do, so I have 3 options here. So my first option, if I don't have any imaginary roots, then all 5 would be real. If I have 2 imaginary roots, how many would have to be real? 3. They're going to add up to 5. If I had 4 imaginary roots, then we would just have 1 real. And you guys can see, if you're working with an even root, like all of these were even. If you're working with an odd root, the imaginary will always be even because they have to come in pairs, but the real will be odd numbers. So you can add up to whatever that odd degree is. And then I got one more here real quick. This is 9x to the 7th. Okay, so in terms of what we have here, it's just the exponent. Nothing to do with the 9, nothing to do with whether that's positive or negative. It's just solely based on that exponent. So if that's the leading term, that's going to have 7 answers. All right, so when I do this, I just do even numbers up to 7. So I'm going to do 0, 2, 4, 6. And 8 would be too many because we're only going to have 7. So this one will have 4 options for how your zeros could shake out. So if you don't have any imaginary, all 7 have to be real. If you got 2 imaginary, you'd have to have 5 real. Just each one of the rows would add up to 7. If you have 4 imaginary, we got to have 3 real. And if we have 6 imaginary, we'd have to have 1 real solution. So those are the 4 different ways that could shake out if you had a 7th degree polynomial. Is anybody having a question? Okay, now, same kind of a concept down here, but we actually have a specific graph of the polynomial, and they're going to tell you the degree. All right, so I'm going to tell you the degree here. So this first one says this picture is a 7th degree polynomial. How many real solutions do you see on that graph? 3. Okay, so I can see right on the graph just x, like 1, 2, 3 real. So then, how many imaginary would it have to have if you know it's a 7th degree? 4, right? It just has to add up to 7. You can see 3 on the graph, so that means it has to have 4 imaginary that we can't see. That way the total will add up to 7. Okay, let's look at this one. If this is a 4th degree, how many real solutions can you see on that graph? All 4 of them, right? 1, 2, 3, 4. So there's all 4 are real. So that means this polynomial, I don't have an equation for it or anything, but based on that picture, if it tells me if it's a 4th degree, then we would have 0 imaginary roots. All right, this guy on the end here, this is 5th degree. So how many real solutions do you guys see on this last graph? Just 1. So then if it's a 5th degree, how many imaginary solutions would it have to have? 4. Perfect. You just have to make it add up to the degree, and you can see the real ones on the graph. All right. It's kind of backwards from that table. With the table, I start with imaginary and do even numbers. With the graph, I would start with real and then figure out what you're going to have to add up to give you the degree. How many real solutions can you see on this 3rd degree polynomial down here? 3. You can see all 3 here. So that means I would have no imaginary solutions. And then I have one more graph down here, and then I'm going to be quiet. That says it's a 6th degree. How many real solutions do you see on that graph? 0. Doesn't touch the x-axis. So there's no real solutions. So whatever that equation is, it's going to have 6 imaginary solutions. Is anybody having a question? Okay. I'm going to give you guys, if the